Uh, I can't think of it, ma'am.
Okay. Pushparaj, 85.
Yes, ma'am.
Where have you seen chain drives?
In motorcycles, ma'am.
Motorcycles, yes. और कहाँ देखा है? राकेश? राकेश, roll number 88. Ever been to any industry? Any one of you? So most of you, I'm sure, was yes. In which machines? An industry, in which machines? So most of you have seen this chain drive in bicycles, since it is fully exposed and you can see the sprockets. You can see this chain drive or this entire chain. You have seen this in motorcycles. There also it is exposed. Since you have not been to industries or factories, you might not have seen, but these chain drives, they are also used in packaging industries. They are used in various agriculture equipments. Again, if you have been to some farms, this is used in printing industries. This is used very much in textile industries. Also used in food factory for conveyors. Manufacturing what? What's your point? This is used in manufacturing of what? Manufacturing of machines? But in food factory, wherever it is used as conveyor belt, there is a chances of contamination because this chain drive is using lot of oil and lubrication. Since it is metal to metal contact, we'll quickly go through what are the advantages and limitations of roller chain drive. Okay, before that, let me finish off whatever images I have here. So you would find the application of chain drive in various industries, in heavy machines, in automobiles, normally in two-wheelers. These are different types of chain based on the design. The most common one is this roller chain. This is what exactly you have seen in bicycles or in motorbikes. So this is a roller chain. With little modification in the design, this is known as silent chain. Here the noise would be considerably less as compared to the roller chain. Again, modification which makes it a pattern like this, named as leaf chain. For this to work as a conveyor belt, if the top surface is flattened, you call this as a flat top chain. As I said, various modifications. So you see the geometry of the chain is modified like this. So the most common ones are the roller chain, bush chain, and the silent chain, out of which the roller chain being the most commonly used drive in the industries. We'll be talking in details about the roller chain. As far as design goes, the overall design, the length of the chain, the cross section of the chain, selection of the chain for any kind of modification would remain by and large the same. Manufacturing would change depending upon its shape. These are different types of chain drives. Look at this assembly. A chain drive can be used for connecting number of shafts. So you see how many shafts are connected here? 1, 2, 3, 4, 5. A single chain drive is connecting 5 shafts. So this is more like an entire train of, like a gear train. We have these train of 5 different shafts connecting. And the best part of chain drive is it is used both ways. So you can have a sprocket on the inner side, you can have a sprocket on the outer side, again on the inner side. And here the angle of overlap can be less than 90 degree also. And you see this angle is around 50 degrees, 50 to 60 degrees, or it could be even less depending upon what is the overlap. So that is the advantage of chain drive. So before we go into details of this, let us quickly talk about the advantages and limitations of chain drive. Okay, what else? Your points. Advantages and disadvantages of chain drive. As compared to belt drive, this is a positive drive, so no chances of slip. Yeah, come on, give me the points from your side. The power transmission capacity is high as compared to belt drive. This is high. This can be used for varying center distance. So unlike gear drive where the center distance has to be small, or in a chain drive the center distance has to be large, here there is a range of center distance for which you can use. Efficiency as high as 98%. What do you think the requirement of initial tension as compared to belt drive? Do you think this requires initial tension? Yes or no? Not required. Yeah, so it is, as compared to belt drive, it is very, very small. It cannot be very loose. It has to have some tension. If it cannot be zero. So this initial tension required is very small as compared to belt drive. Then one major advantage over the belt drive is this can be used even at high temperatures. So that is not a consideration. Whereas in case of belt drive, this is when we are comparing it versus belt. Gear drives can as well be used for high temperature, but belt drives cannot be used. Installation is easy. So not very precise center distance is required. Then this lies somewhere between gear drive and belt drive. So it is flexible compared to gear drive and it is rigid and a positive drive as compared to belt drive. So this is lying somewhere in between this. You can work with small angle of contact as I have shown you. the angle of contact can be even less than 90 degrees. So it could be greater than 90, but here you can work with angle of contact less than 90 degrees as well. Again, as compared to belt drive, where you can never have an angle of contact as small as 40 or 45 degrees. And as we have discussed and seen in the figure just above this can transmit power to number of shafts. So this could be 3, 4, 5, 6 shafts connected together. Large number of shafts with single prime mover. And this is possible because both the sides of the chain can be used. Okay, now you have to tell me the limitations. You cannot have a product which will have only all good points, right? Limitations, backlash. What do you mean by backlash? What is backlash? Okay, how do you define backlash in gear drive? Lubrication is required, yes. It's only because of the lubrication that the noise can go down. Yeah, power cannot be transmitted for long distance, so long as belt drive, yes. So center distance has to be less than that of belt drive. Manufacturing cost is definitely higher as compared to belt drive. What about smoothness of the operation? As compared to gear drive or belt drive, would this be smooth? This is not smooth and it is noisy as well, which is due to chordal action. We'll see what is chordal action. We'll talk about chordal action. The major disadvantage is the peripheral velocity has to be limited. This cannot work at very high peripheral velocity for the roller chain. If you want to increase the peripheral velocity, then you'll have to modify the design. Like you can use a silent chain or some other variant of chain, so that this chordal action, this noise level, this goes down. So this says limited to 500 to 600 meters per minute. Belt drive you can go for 1000 meter per minute, 1200 meters per minute. So what happens if VP increases other than noise? Why there is a limitation to peripheral velocity? Yes. Saurabh? Chain will slip at high velocity? No. It's not because of high speed that it would slip. It would slip if it is loose. If the assembly is not proper, then it would slip off. Any other reason? What happens in case of belt drives? at very high velocity, what happens? If you go on increasing the peripheral velocity, what would happen to, or what is an undesirable factor coming into picture? Manas? Anvi? Anybody can guess? Siddharth? Centrifugal force, yes. So as you go on increasing the value of Vp, this centrifugal component increases, and since here the weight of the chain is high as compared to a belt is made out of soft flexible leather. This is made out of metal. So as its mass increases, as its density increases, the value of Fc increases. And this becomes really high, and this is undesirable. So the centrifugal tension, this limits its peripheral velocity. Peripheral velocity is also limited because then this chordal action increases, and at higher velocity the noise level increases. Noise increases at higher velocity of Vp, and this requires more lubrication at higher velocity. To reduce the noise, to reduce the friction, more lubrication is required at higher peripheral velocity as the value of Vp increases. So these are certain limitations of chain drive. Manufacturing, again, as compared to belt drive, it is difficult. Design, you would see in the coming classes, this is again difficult. This requires very precise design of belt and chain and sprocket, chain and sprocket. And that's the reason, like V-belt, the chain and sprockets, they are also standardized. So we are not going to design, we are again going to select a chain. So we have standard charts for chains. So we select chain number 40, we select chain number 42 likewise. So we'll select a chain from the design data book, and you get a combination of chain and sprocket. So if you have to replace a chain, you replace a chain of same length and same number. So we'll see what is this number and what does that number represents. So as I said, the most commonly used chain is a roller chain. This is what we are going to study and design. A roller chain looks like this. जो अपनी साइकिल में देखा है, that is this roller chain. So look at this design. This is showing you one set of roller chain. So it is like you have this link plate. This is this link plate. So in between these two link plates, you have a pin. Outside this pin, there is a bush and there is a roller. So it's because of this roller that the power is getting transferred smoothly, and so this is known as roller chain. There is no sliding motion during the transfer of motion. There is no sliding, it is pure rolling. And this is the roller which is rolling continuously outside this pin. So these two plates, they are brought close to each other. Inside this pin goes over the pin. This is showing the roller, and this one set of link plate with pin and roller. Likewise, there would be another set, and this is connected through another pin here and an outer link plate. So this is an inner link plate, then there is an outer link plate, and it is this roller. In case of bush chain, the roller is replaced with a bush. So this is simply a soft bush, which makes it a bush chain. So we are going to discuss in details only about this roller chain. And these link plates, they are made of alloy steel. Normally it's a chrome steel. It's an alloy of chrome, and this is normally obtained by stamping. Do you know what is stamping? I'm sure you have studied this in manufacturing process. What is stamping? Stamping, somebody? Vaishnavi studied this in manufacturing process? Vedant? Vedant Mahure, you are there? It's a pressing operation wherein it is pressed between the two dies to get the required shape. That is stamping. You are correct. So Siddharth is not there, Vedant is not there, they are sleeping, I guess. What is the point in simply joining the lecture and then, if you are not there physically, Siddharth and Vedant, whatever. Okay, so this, as I said, without the roller, a similar kind of assembly is known as a bush chain, again having inner plates, a pin in between, and the outer link plate. This pin is covered with a bush. So this is a bush chain. Okay, so Vedant is there. Mic is not working. Okay. Siddharth is absent. Okay, so as you understand that we are designing anything keeping in mind what? What do you design for? What is that keyword for which we have all the design considerations? Vedant? Yes, please. Bharti, Prabhat. What is our key consideration in design? Shantanu? Power? Okay, so if you want to transfer very high power, you will go on designing it for high power transmission. Is that true? Failure, yes. So the keyword is failure. So unless you know how a particular component fails, we cannot design. So we must know how it fails first, and accordingly we design to avoid this failure. So what do you think how a chain drive fails? So here comes the next question. Rishabh? Rishabh Verma, you are there? Rishabh? Rishabh is not there. Rushika, are you there?
Yes, ma'am.
How do you think a chain would fail?
Maybe due to excessive load.
Excessive load? Not exactly. Shashwat? Shashwat? Wear, fatigue, improper lubrication. So these are indirect reasons: excessive load, lot of wear, fatigue, improper lubrication. Yes. So basically all these are indirect factors. But because of improper lubrication, because of wear, because of fatigue, again wear and fatigue, because of excessive loading, how would you see a chain is failing? Do you think the link would fail? Failure of pin. Okay. So do you think this pin will shear off into two parts? Plastic deformation of pin, as in the shape would change. Do you mean to say that? Do you mean to say that this pin will change its shape? Okay, anybody else can think about how this fails? So it's a failure of pin, that is true, but it is not like the pin will shear off into two pieces. Okay, so this is the pin. This is surrounding with the roller. So you would be surprised to know that the failure of chain is marked or observed by increase in the length. Increase in the length of the chain is taken as failure of chain. The link will never break. This link will never break. The reason is the factor of safety is very high. It's of the order of 10, 11, 12. So for whatever amount of loading, this is not going to fail. But because of overloading, this pin, this which is continuously moving, this will undergo wear, this will undergo fatigue, and if the lubrication is not proper, this will undergo reduction in diameter. So this pin, this will become thinner and thinner. Length would remain the same, its diameter goes down. The moment its diameter goes down, this pin, this link will move on this side, this link will move on this side, and the gap between the hole provided in the plate and the pin, this increases. This takes place in one of the link. Likewise, we have so many links, and total chain length would increase. So if the increase in the length is more than 3% of the total length, we say it is failed, and you have to completely replace the chain. Complete replacement is required. So after the increase in the length by 3%, we cannot wait further for link to fail or pin to fail. And so it is said that a failure is only by increase in the length. So I repeat, whatever points you were giving me, they were right, but they were the indirect reason. So it's not like as in case of gear, the tooth would fail, or as in case of belt, the entire belt might fracture, it might rupture, or the joint of the belt that might open up. So here the failure of the link is only by increase in the length of the complete chain, and that happens because of reduction in the diameter of the pin. So we are going to design it for the strength of the pin, for the bearing pressure of the pin. And this would go down if we have proper lubrication. So wear would go down, as you understand, with good lubrication. And so while we are selecting the chain to find out, to estimate its life or the safe design, we have 3 types of lubrication. So while you are designing, you have to also mention what is a type of lubrication. So type 1 lubrication is if the peripheral velocity is low. Type 1 lubrication is intermittent lubrication. Intermittent is when you are adding few drops of lubricant. Intermittent lubrication. So you are adding few drops of lubrication, like you do in say sewing machine if you have at home, or in your bicycle if you are putting lubrication using few drops of oil, mineral oil. That is type 1 kind of lubrication. Type 2 lubrication is at intermediate speeds. So if its maximum peripheral velocity is 500, 400 and above, we call it high speed. Low speed would be anywhere around 100, 150. Intermittent is in the range of 200 to 350. That is intermediate speed. So at intermediate velocity, we want the chain to pass through a shallow oil bath. A shallow oil bath would be, if this is one sprocket, this is another sprocket, this kind of lubrication is not there in case of two-wheelers. Is the bicycles are moving at low peripheral velocity. If this is the chain, you can have an oil bath like this. So after every round, this lower part of the chain, this will go through the oil bath. This is intermediate or type 2 lubrication. And type 3 is where it is rotating at high peripheral velocity, and this requires an oil pump. So it is a forced lubrication with the help of an oil pump. So while we are designing a chain drive, we will also specify the type of lubrication based on the peripheral velocity. So lubrication can increase the life by as high as 100 times, 200 times, 500 times. So proper lubrication is must. This is the key to the success of the chain, even if it is properly designed, but if the lubrication is not good, then the life would go down. Life increases with proper lubrication. So, as we have seen, the links are manufactured by stamping. The pins are then riveted. If you have seen this design of pin over here, pin head. The pin is inserted and it is fixed to this plate. You will have a rivet head, and on the other end also you can stamp it, hit it, hammer it to make it flat. So this is riveted, and the bush and the roller, they are press fitted outside the pin. Now while we are selecting the number of links, or we are calculating the number of links, we have to make sure that number of links are always even. Because the design in the top view is like this. This is connecting. Here is the pin. Likewise, here it is connecting. This is the pin here. So connecting these two rollers, this is one link. Again, connecting next to, you will have one link. So we always get even number of links. So if you come out with a calculation saying 42.3 or 46.4, we have to have an integral number. So we'll go with either 42 or 44 or 46. So it's always having even number of link. And the length of the chain is never mentioned in millimeters or meters, unlike belt drive. So length of a chain is always measured in terms of number of links. So number of links, as I said, would be 40 or 50 or 60 or 64. Suppose the length of the chain is such that it is not possible to have even number of links. Suppose this is a rare case. Even number of links is not possible. What would you do? what would you do? The solution is an offset link, rarely used for the situations where it is impossible to have even number of link, and this is an offset link having a roller here and a pin here. Otherwise, the design is such that, going back to the same image, look at this. So this is one link with two rollers connected with an external link having a pin, again a set of two rollers and an inner plate. So it is always like this, and so you always have an even number of links. But suppose the case is such that if you reduce it by one, the length is getting shorter, or it is becoming too tight between the sprockets, and if you increase the length, then it becomes too loose. The center distance is fixed, you cannot alter. Only in that case, you have to go with odd number of link, and at the end, wherever you are closing this chain, you have to use this offset link. An offset link is a link having a shape like this, which will have roller at one end and pin at other end. This is known as offset link. Yeah, so somebody was saying that the failure is because of wear, which is true. So even after giving so much amount of lubrication, if the wear cannot be avoided, what else can be done to avoid or to reduce wear? Again, the clue is manufacturing process. Yash, Shinde, Shivesh. Are you there? Yash, Shivesh. What do you think would reduce the wear? These are all metal parts. Shubham, Shreya. How do you improve its hardness? How do you increase the hardness? Sushmita? Yes. So different kind of heat treatments are given so that the hardness improves and the wear reduces. So by the reduction of wear, we can increase the life of the chain. That is another important point why this is made out of metal and how it can be heat treated. Since it's a pure rolling between the pin and the roller, it's a rolling motion rather than a sliding motion. Coefficient of friction is small. And designer of sprocket, they also suggest that the number of teeth on the sprocket should be odd. And with experiments, it has been observed that with odd number of teeth, the wear is more uniform. All the teeth will have same amount of wear. It will not be a non-uniform wear. So this is observed from number of experimentation. With even number of teeth, the wear is not uniform. So few teeth would undergo more wear, other teeth would undergo less wear. So if you want the sprocket and the teeth of the sprocket to undergo wear uniformly, then number of teeth must be odd number. And since the failure criteria is the failure of the pin, so the bearing pressure of the pin is to be studied or considered, bearing pressure of the pin, this becomes our design criteria or failure criteria. So if this is our pin, we are talking about this area. So as its cross section reduces, as the bearing area reduces with wear and tear, if this bearing area of the pin is small, this will undergo more wear. For the same load, if the area is small, obviously the wear will go up. If the wear goes up, then the diameter of pin would further reduce. If the diameter of the pin becomes smaller than the slot or the hole which is provided, the pin would move towards the ends. When I say end, this is the link, these are the holes, and it should have a pin of same size. But since the pin is, its diameter has reduced, this pin is here and this pin is here. And so the two links, they are getting away from each other, or we say the length increases. Increase in length is the failure. This leads to failure. Okay, in 5 minutes, we'll quickly discuss the chordal action and then we'll stop. We'll see what is the meaning of chordal action of the chain drive. Some days my tablet and pen, they are not supporting me, and this handwriting is coming out to be horrible like anything. In case of a chain drive, the sprockets would look something like this. This is the shaft. This is our chain. So each link here is moving like straight lines, as if these are the chords. You know what is a chord? If this is a circle, this is a chord, this is a chord, this is a chord. So unlike belt, which is flexible, which is moving continuously, here these links, they are moving like chords. And it's because of this movement of chord that this comes here and then it has to change the angle, the relative angle between these two, till the time it leaves the sprocket and then it becomes a straight line. Again, while it has to go through the sprocket, it has to bend and its angle is changing. While the angle is changing, it will rub against each other because it's a metal. So the two link plates, they are rubbing each other and that is creating a lot of noise. there is an angle of articulation. So before it takes this shape, initially it is somewhere located like this, and then it comes here. So this angle is known as angle of articulation. So otherwise it would continue to remain in this position, but it changes the shape here since it is connected to the remaining links. So what is this maximum angle? This is known as angle of articulation. So what should be this angle of articulation? It should be small or it should be large? Should this angle of articulation be small or large? So this angle of articulation should be as small as possible. This will reduce the smaller the better. This will reduce the caudal action, this will reduce the wear, and this would be better. Now the caudal action would be less, which depends upon number of teeth. Suppose the number of teeth are only 4. So if your sprocket is like this. Oh my god, this is looking really bad. Please don't mind. So now your chain is looking like this with only 4 number of teeth. So here the angle of articulation would be as high as 90 degrees. If I go on increasing the number of teeth, this angle of articulation goes down, so the caudal action goes down. So it's always better to have more number of teeth to have a smaller angle of articulation. We need to have more number of teeth on sprocket. With more number of teeth, this distance, this is known as pitch. Pitch length would also reduce. So if this is made out of number of small chords, by definition, circle is made out of infinite chords. So if this chord lengths are small, if this pitch is small, then the motion would be more smooth. But in that case, number of links would increase, isn't it? If the pitch is small, this is a chain drive with large pitch as compared to this one. So I am reducing the distance between the pins, but I am increasing the number of links. Here I am using only 2 links. Here I am using 7 links in the same space. So with more number of links, the weight increases, the cost increases, the price increases. And for the smaller pitch, if I am going with a smaller chain, then its power transmission capacity reduces. So we have to continuously work with what happens for a smaller pitch, and if you want to improve the power transmission capacity, what do we do? And then comes into picture a double roller or a triple roller chain. So a double roller chain would be when between the sprockets there are 2 set of chains. So this is one layer of chain, and then there is another layer of chain. This is known as a duplex chain. This is one layer and this is second layer. Likewise, you can have a triplex layer of chain, you can have a quadruple layer of chain, and every time the number of layers of chain is increasing, the power transmission capacity also increases. Do you have your design data book, PhD design data book handy with you? We'll have a quick look on this duplex and triplex chain, how the power transmission capacity increases. I'll give you the page number. The chain drive 7.71 as per my book. Please refer to it quickly. Can you see 7.71? We are referring to PSG design data book. Bush chain is shown, roller chain is shown, a simplex chain is a single layer, a duplex chain is shown, and a triplex chain is shown. How do you denote simplex, duplex, and triplex as given in the data book? What is given in the data book? Yes. No, it's not A1, A2, A3. R and B are denoting simplex, DR, DB are denoting duplex, TR and TB are denoting triplex. And look at the load carrying capacity. For R range roller chain, the load carrying capacity is 300, 460. For double duplex chain, the load carrying capacity is 800. And for triplex, the load carrying capacity is 1140. So accordingly, the load carrying capacity increases with increasing number of chain. So we'll be solving problems on this chain drive in the next class. You are open to ask questions if any. Do you have any questions or whatever we discussed till now? Yes, anyone?